So we have 4 papers, like I said. To all the speakers, the timekeeping is already done by Bob, so please take a look at it. After 16 minutes, we'll show you 2 minutes.
No, first I'll show Q&A. No, I think this one goes first.
2 minutes left, and then when
that's over, then we go to Q&A.
And then when Q1.
And then when it says time has ended, that means
the end of time.
Yeah, time, all time has ended. So.
I don't think there's anything else that I don't need to talk to DK. The reference on generative AI, you want the details.
Thank you. All right, so I want to present this generative AI, human creativity and art. It's a joint work with a student there, Eric Zhu. So I think everybody here knows that last year, image to text model plus artist won an art competition, right? They call our state fair, and people didn't know about it until they, the author said it, and then lots of people are pissed. Judges were, however, not so pissed off about it. They still liked it, and since then there have been lots of things, competition, art competition, being entered by these models and humans. Right? So here is a bit of a history of text-to-image AI. So the first one, it was a GAN-based one. And then there came, after that, a bunch of different things, but it started becoming mainstream when Midjourney DALL-E 2 Stable Diffusion became mainstream last year, right? So that was, you can see approximate number of users, probably more now, and we have come far away from 2017-ish. So this work is related to computational creativity. So early work has actually been trying to understand philosophical nature of creativity. What is creative? How do you define that? How do you generate that? How do you recognize it? All of that. And how can computer-generated artifacts be evaluated as creative artifacts? And for that, in this literature, widely used criteria for creativity is novelty, which is how different is an artifact from a known artifact in its class. And value. It's a utility, performance, and or attractiveness of an artifact, and it's very heavily contextually dependent. Right? Different contexts require different types of value to be defined. So in our research, our questions are: 1, how does adoption of generative AI affect humans' creative productivity? This first punch, a very obvious question. Is generative AI enabling humans to produce more creative content? And then lastly, for whom and when is Gen AI effective? Is our set of research questions. So our data set is, we got the data from our sharing platform, about 5 million posts, 50,000 unique users, and 6,000 known AI adapters, with about 1.5 million images, more than 10 terabytes of data. So they actually say, artists, when they use these tools, it needs to be identified, but not everyone does. And so that's a problem if you're trying to use like tags and text to identify. So what we did took a bit of time. As expected, tags-only methods misses a lot of actual AI-generated art because many thousands of people don't even disclose or have anything tagged. Now, how do you use that? So then we built our own custom multimodal image detector. If it's published after January 2021, and if it's not, that's no AI. They didn't have tools to use that. Then we use an NLP-based classifier using description and tags. Then if we couldn't really tell it, then we actually used the vision algorithm. And this is some results that we did with the latest Dino V2 from Meta. And the test accuracy about 92, depending on the different modules. So this is adoption timeline. You can see that Midjourney has been released in about 2022, and DALL-E 2, and then Stable Diffusion. These are our samples of adopters when we identify them to adopt based on this classifier. And we use difference by Callaway and Santana because we assume that there is a difference between people adopting at different times. We also balance them using PSM. And here are the outcome variables, very simple. Productivity is the log of monthly number of posts. Value is a favorites per view, right? So a novelty is a pairwise distance for each artifact compared to all other prior existing art pieces. Here's a bunch of different ways you can be creative as an artist on the platform. So we did some multimodal feature extraction. So humans can express creativity via two, largely, there are probably more, but largely two main ways. Content and visuals. Content has to do with the focal object and relationships between depicted in the artifact. And the visuals consider the stylistic and thematic elements of an artifact. It's at this pixel level. And so if you see an example here, this would be same content and visuals. So you got cat here, they kind of look the same visually, right? You have a different content. This one is like a dove, and then this is just like tree, but similar looking visuals, right? You can imagine they're from same sort of like cartoon or something. Different content, right? But same visuals again here. Yeah, I messed it up. This is, and then different content and visuals. So this is basically different contents and visuals. This is different, same visuals. Yeah, different content. I just repeated myself. Thank you. So content feature. We did content feature extraction with lit2, so you can sort of see here, this is pairwise cosine distance based on captions. So we used lit2 from Salesforce to get the caption that describes the content of the image and compare that using the text embedding. So you can see this is close to that, right? But this is not as close to this one than say cat, right? Because both are cat, right? And if you look at this, another example, it's definitely close to this one. Waterfall and trees and mushroom, it turns out it is closer to that one than say a cat. Okay. For visual extraction at the pixel level, we use Dino V2 again, that's from Meta. So you can see here, this is working at the pixel level and extracting visual stylistic differences or similarities. You can see here the cosine similarity between these two are more similar, and as you go down, if you change the color, it's a bit less similar, and then as you go down, it's a very wildly different mushroom and that art. Right? So data exploration. So here's an average user, one user, and around 2020, they started, this was like their art piece, like Pokemon-looking art pieces. And then this person announced that in September 22, they are new and improved. And we identified that they actually adopted the Gen AI tool. And since then, these are the things that this person started creating. And some evolution of what happens to an artist after they adopt. So this is, among our data set, some examples of most novel content. So we can see fractal landscape. It's content-wise novel, and you have a transmagnetic excitation field. Content-wise, it's supposed to be novel. And this is least novel when you have mountains, and it doesn't even have a title here. We're doing 714. This is most novel visualistically at the pixel level. This is what our algorithm sort of chose out. So opal dragon scale and the sea within a sea. Then this is the least novel visual. So looks like all the art that we have seen traditionally. And this is the value, the most valuable versus, someone uploaded a Shutterstock photo on the art sharing website. I don't know why this was not so liked. All right, so let's go into the results. Okay. Significant lift in creative productivity. So as artists adopt, they obviously increase their throughput. In the first month, increased by about 50%, and second month about 100% of their original sort of production. For average adopter, this amounts to about 7 per month, and adoption during the adoption month, and 15 additional posts in the following month. And it stables down to about 25% above the normal. Over time, value of the product produced artifact also increases. So overall, this amounts to about 1% increase in the likelihood of receiving favorites per view. And this is over 50% increase over pre-treatment rates at 2% favorites per view. Okay. So significant increase in the value as measured by favorites per view as well. Okay. Here's the impact on the average content novelty, which decreased over time compared to prior artifacts. So content is basically what's in the image, right? And that's basically the average content novelty is decreasing. But while average content novelty decreases, max novelty suggests exploration. So people are, on average, producing more, similar content-wise image artifacts, but the universe of novel stuff is increasing because the novelty, the max novelty content is actually increasing. Okay? This is because they have more, they don't have to spend as much time, so they're able to explore more ideas, right? Producing these things. Visual novelty decrease over time, it's very strong. Why is this? Because obviously they're using the same set of tools, right? And they're generating these visually pixelized, similar looking photos or arts. But who's really winning and when? And for example, these tools, adoption of these tools decrease average content and visual novelty in aggregate, but what happens at the individual level, and for whom and what type of novelty bring value, increase in value. Okay, so what we can do is we can bucket adopters based on bottom, middle, and top 33%. So the first 99 percentile, and then we also looked at the best top 1 percentile. Right? So this is basically, we got their pre-treatment content and visual. Before they adapted, we ranked them on their content novelty and visual novelty. So what were they doing and what were they excelling at before they adapted? And then we see the impact of adapting. Okay? That's on value, their value. Right? So if you think of content novelty as ideation ability, or their sort of thinking ability on what kind of content do I want to generate, you see here that best idea, you can see this one is a mean visual novelty and mean content novelty, bottom, middle, top, and best. You can see that the best ideators, so if they increase value by executing on more novel visuals. Okay? While all tier realize value gain by producing more novel content ideas, 99% garner a much larger effect. So if you're, you see a stark difference here, right? We did the same thing with the visual. So if we think of visual novelty as an individual's execution ability, their mastery over pixel level visual generation, this is the same sort of impact we see. The most mechanically skilled artists are penalized for producing even more novel visuals than before. Sort of, that's like a decreasing margin, right? If you are already good at the pixel level and visual level, if you increase it, it's not going to be, awarded. However, across all different skill levels, more novel content ideas are rewarded handsomely. Okay? So, in the land of the mid-journey, content is king. So what we have is here the SHAP value for novelty metric over time. So SHAP value shows you predictive power on Y, and Y here is the value, right? So as time goes, months since adoption, content novelty is highly predictive of value over time. It kind of makes sense because visuals sort of stay over, it's produced by the same thing, and people are used to seeing same sort of visuals over and over and over again. As opposed to content novelty, which, it's up to your artist to come up with that creative idea, right? So that's winning over. And so here's a takeaway. Productivity increases by 50% during the first month, and then converges to about stable 25%. Value measured by favorites per view increased by 50% relative to pre-treatment value. Average content novelty decrease over time. However, max novelty still increases, suggesting there is still an expansion of creativity. Average visual novelty is decreasing. And winners and losers are divided based on their pre-adoption characteristics. All right, that's it.